Hey, it's Dr. J. Our final chapter is going to be chapter 13, probability. So I'll call this part 1, the introduction to probability. So the simplest way to begin, discussing, probability and is to use a coin. There are two sides to the coin. This is the heads, and this is the tails. And so we're going to perform a little experiment using the coin and flipping the coin, of course, and determining what's the probability of a particular outcome. So first we're going to need some terminology. So here are some definitions so that you'll know what the heck I'm talking about through the probably three parts of this lecture. So definition number 1. The observation of a random phenomenon is called an experiment. So in mathematics, we don't have chemicals and beakers and Bunsen burners and lab coats. A mathematical experiment is simply observing a random phenomenon, and we call this an experiment. The different observations, so if we observe something different, they are called outcomes. So if I flip this coin, it landed on tails. That's an outcome. If I flip it again, it lands on tails again. That's the same outcome. Yeah. So you have to make a different observation in order for it to be a different outcome. In order to get a different outcome, I got to get heads. I got heads. Yeah. So we have the different outcomes. Those are the different observations that are called outcomes. The set of all possible outcomes is called the sample space. So if I flip this coin one time, there are two possible outcomes. I know I had to flip it 3 times to get the 2 outcomes, but I was just trying to demonstrate the 2 sides to the coin. If I take all the possible outcomes, in this case there are 2 possible outcomes, that's called the sample space. And an event is a subset of the sample space. Okay, so we have 2 possible outcomes for flipping the coin, tails or heads. That would be the sample space with 1 flip. The event is one of these possible outcomes. It's a subset of the sample space. So with a coin, there are really only 2 possible events. I can either get tails or I can get heads. That would be with 1 flip of the coin. We might have to have a more complicated experiment with multiple flips. So these are the basic definitions in terms of vocabulary. I'm now going to give you some mathematical formulas that's going to allow us to compute the probability mathematically, come up with a number that represents how likely something is to occur. So, sample space. we usually use the letter S for sample space. And we'll start with the letter E for event. Although I won't always use the letter E for event, I will whenever it's possible or feasible. If we have multiple events or I've already used the letter E and I want to use another event, I obviously would have to use a different letter. I can't always use E. But for the basic introduction and for the first formula I'm going to give you, I'm going to write everything in terms of E. Okay. So we define the probability of E occurring. So we want to know how likely is it that this event E will actually occur by PE. P of E, or the probability of E occurring, to be the number of occurrences of the event E. In other words, how many times does that event occur? Divided by the number of possible outcomes. S. In S. In other words, how big is the sample space? How many things are actually in the sample space? For the coin, one flip on a coin, the sample space is very small. There's only 2 possibilities, and we'll get to that in a second. We want to symbolize this so that I don't have to write number of occurrences of event E, number of possible outcomes in S. That's just too much. So we have a nice mathematical recipe that we can write using N for the cardinality or the number. So it's the cardinality of E. Remember, N stands for cardinality. We actually learned that in a previous chapter. It's just a fancy way of saying the number of things in that set. And N of S would be the cardinality of S. In other words, how big is the sample space? Probability is always a fraction when you set up the formula. Sometimes we simplify it into a decimal, but no matter how you write it, it is always going to be a number between 0 and 1. Always. So you can, if you calculate one of these probabilities and you get a number that's larger than 1, or you get a negative number or something like that, you definitely made a calculation error. You're always going to get a fraction between 0 and 1 inclusively. So you could actually get 1, you could actually get 0, and we'll discuss the meaning of that next. So you're going to calculate, or you'll be calculating this value and checking, at least mentally. We don't always do this part. I'll put this part in the cloud. So when you do the calculation, keep this in your mind that you better have a number between 0 and 1. It's not necessary that you write out this inequality every time you do one of these problems. You just want to keep that in your mind that you should get some decimal or fraction that's between 0 and 1. Intuitively, you can think of it as a number line between 0 and 1, and then you've got 0.5 or 0.50. We like to write it as 0.50 because it looks like 50 cents or half a dollar or something like that. It gives it some sort of decimal value. It means the same thing as 1/2. You all know that. And so intuitively, what it really means is if something has a probability of exactly 50%, or 1/2, these all mean the same thing. This means that the event is equally likely. or not. In other words, the chance of it happening and the chance of it not happening, whatever that particular event is, again, back to the coin again, we would say that it has a 50-50 chance. We often use a colon for the symbol of a ratio. 50% chance that it will happen, 50% chance that it will not happen. Okay. If something has a probability of 1, that means it is absolutely certain to happen. It will definitely happen. We say 100%. Absolutely going to happen. And if something has a probability of 0, it is not going to happen. So 0% chance, yeah, the event will not happen. Well, let me say that again. There is a 0% chance that the event will happen. In other words, there is a 100% chance that it will not happen. So, and you could say the same thing over here. You know, there is a 100% chance that the event will happen. So therefore, there is also a 0% chance that this event will not happen. And then in these sort of gray areas between 50% and 1, you have what we call more likely than not. So anything in between here, between 50% and 100%, is more likely than not. Yeah? It's a good chance that it's probably going to happen. And if something happens between, an event has a probability between 0 and 50%, we would say it's less likely. Yeah. In other words, less than 50% chance that it's actually going to happen. So you could say less likely than so. More likely than not, less likely than so. Okay. So that's just the basic terminology. There's another term that you might see thrown around once in a while when people are talking about probability. To say something, to make it sound fancy, they will often call this relative frequency. That's more of a show off kind of word to make you sound like you know what you're talking about. So the relative frequency is 50%. You know, it means exactly the same thing as the probability. Okay. Frequency is a mathematical term for how often something happens. How frequent does that event occur? Okay, so that puts all the terminology and our most important formula, the probability of E occurring. I'll write the formula down one more time. It's the number of times that E could occur, number of possible occurrences of E divided by the number of outcomes in the sample space. As I discussed earlier, as I alluded to earlier, the experiment of flipping a coin one time has a 50% relative frequency, or a 1/2 probability, or you would say a 50-50 chance of occurring. Okay, so I guess we'll do one example, or maybe two, to get this going here. Example 1, a single coin flip. Just so that we can see how the formula works. What is the probability of heads? I mean, I know we already know the answer, but what a better way to start out than just show you how this formula gives you the intuitive result that you've probably known since a child when you flip a coin to decide who wins or loses, or who gets the ball first, or whatever. Okay, so our event is heads. This is what I meant earlier. Sometimes we just use the letter H instead of the letter E because, but I want to show you the formula, so I'm going to say E. Okay. And so the size of E, there is only one head on the coin. There's only one head on the coin. Yeah, there it is. So maybe I should show it right side up so you can see it. So there's the head. There's only one possible event, one outcome that's a head. Yeah. S is either heads or tails. So it's technically a set. I'm using just the letter H for heads. We're not really going to use the set braces. I might as well stick with the concept of it being a set, but in general purposes, you would just say HT and not really use the fancy set notation. Needless to say, you are really only interested in the number of items in the set, so the cardinality of this set is 2. There are 2 items. So the probability of heads, probability of E, and again, you better be clear that E actually means heads. Sometimes it's nice to just use the letter H in that case, is 1/2. Number of recurrences of E is 1. Size of the sample space is 2. And so it's 1/2 or 0.5 or 50%. These are all tomatoes. Yeah. Tomato, tomato, tomate. Not a very interesting experiment, but it is useful for getting the terminology out there and understanding how to actually compute the terminology, to compute the probability. Okay. If we flip the coin multiple times, then we increase the number of outcomes. Example 2. If you flip a coin 3 times, what is the probability of getting all tails? So tails every time. I guess I should put a question mark because I'm asking a question. So what's the probability of getting 3 tails? So now we're going to flip the coin 3 times. And then we're going to record the results. All right. It'll be interesting if I get 3 tails. I got 3 tails. All right. I couldn't have planned that any better. I just got tails 3 times in a row. So what probability did I just demonstrate there? What was the chance of that happening? Why do you think I was so surprised about it? Because it's very unlikely. Well, how unlikely is it? Where is it on that spectrum, between 0 and 1? It's got to be somewhere in there. Yeah. So we're going to flip a coin 3 times. So let's look at the sample space first. And again, now I'm not going to use the fancy set braces. They're unnecessary. So I could get heads, heads, heads. Yeah. Heads, heads, tails. Heads, tails, tails. Heads, tails, heads. Those are all the possibilities where the first outcome is a head. I could get tails, tails, tails. Tails, head, tails. Tails, heads, heads. And tails, tails, head. Now, this is only 3 flips, so I just use the old trial and error method. If you don't want to use trial and error, you can use a counting formula from chapter 12. Yeah, there are 3 flips. There are 2 possibilities for each flip. So 2 times 2 times 2. So there's a total of 8 outcomes. Yeah, 2 times 2 times 2 is 8. Make sure I got all 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. I got all 8 possibilities. Notice that only one of these possibilities is the event of getting 3 tails. So this is my event, E. And the size of the event E, the number of times that happens, is only 1 time. There was only 1 time out of 8 possible outcomes that I could have gotten all tails. So therefore, the probability of that event happening is 1 out of 8, or 0.125, or you could say 12.5%. All of these answers are correct. The most common representation in this particular section is a fraction, but there are a few examples that use decimals, and there are even less examples that use percentages. Percentages are usually quoted and cited on the news. You know, there's a 12.5% chance of rain or something like that. Percentages are used in the media more than they are in the actual calculation that I do on the board. But if you're talking to somebody, you can say, yeah, 12.5%. Yeah. 1 out of 8 or 1/8 is the way that I'm going to list it in this example. So interesting, I just got 3 heads. I only flipped the coin 3 times. I didn't stage this experiment, and my coin is a fair coin. It's not like it's weighted or anything to land on tails. So I actually beat the odds. Yeah, that's less likely than so. Yeah, it probably wasn't going to happen, but it did. Okay, so I sort of what you call beat the odds. Yeah, the odds were against me. And we're going to get to the actual concept of odds in part 2. For now, I just wanted to get this out there so that you can maybe at least get started on the homework, or maybe start reading or getting into the topic. Tomorrow we'll do some more complicated examples involving dice and poker, or cards in general. So tune in tomorrow for the second part of the probability lecture. Consider yourself thoroughly introduced. Dr. Jordan, signing out.